Hello everyone, I'm Yusuke Horizumi. I will now begin my presentation with this title. Best regards. Aminoglycoside antibiotics and decrease the fluidity of lipid membranes, which renal damage and autotoxicity. And therefore, the effect of drugs on the physical properties of lipid membranes needs to be evaluated. Lipid peroxidation has been evaluated in some studies to examine the physical property of lipid membranes. For example, there is a report that peroxidation, which improves the fluidity of lipid membranes, suppresses lipid peroxidation. Local anesthetics are among the drugs for which the physical properties of lipid membranes has been extensively evaluated. Therefore, the local anesthetics LL, lidocaine, and tipicaine were used as model drugs in this study. Liposomes are made of egg yolk resin, which is rich in unsaturated fatty acid. Unsaturated fatty acid reacts with free radicals in the body, causing the following chain reaction, resulting in lipid peroxidation. But liposomes were prepared as follows, and monolayer liposomes were prepared. To evaluate the effect of LA on lipid membranes, we modeled an inhibitory system for lipid peroxidation using drugs and derivative of vitamin E that inhibits lipid peroxidation in vivo. Lipid peroxidation was generated by the Fenton reaction after prior addition of lidocaine and tipicaine. The teobalvitic acid TBA method was used to measure the degree of lipid peroxidation. The TBA methods quantify the red side with a peak absorbance at 530 nanometers generated by the reaction of TBA with metabolites or lipid peroxidation such as malondialdehyde. The graph below shows the spectral measured by the TBA methods using actual reaction of each drug and Fenton reagent. The left graph shows that the absorbance peak at 530 nanometer increased specifically only when SV and Fenton reagent were included and when MTA was included. On the other hand, the absorbance at 455 nanometer was also increased for both SBs and Fenton's reagent. Furthermore, the absorbance at 455 nanometer increased specifically when Fenton reagents alone and Trox plus Fenton reagents were used. This suggests that the absorbance at 455 nanometer is not due to lipid peroxidation. Based on these findings, we investigated the effect of LA on the inhibition of lipid peroxidation by drugs. This is the spectrum of SUV suspension when the concentration of drugs was shaken for each concentration of lidocaine. From this, lidocaine and drugs decreased the absorbance at 530 nanometer in a concentration-dependent manner. The absorbance at 530 nanometer indicates the degree of lipid peroxidation, indicating that lipid peroxidation was inhibited by drugs and lidocaine respectively. The absorbance at 455 nanometer changed, but was not concentration dependent for either drugs or lidocaine. This suggests that the absorbance at 455 nanometer is not related to lipid peroxidation, but is affected by substances that react with TBA. Similarly, the spectra were obtained when the concentration of drugs was shaken for each concentration of lidocaine. From here, lidocaine decreases the absorbance at 530 nanometer in a concentration-dependent manner. DPK decreases absorbance at 530 nanometer in a concentration-dependent manner, indicating that DPK decreases absorbance at lower concentrations than lidocaine. From those results, we extracted the elements necessary to explain the data called singular value decomposition, SVD, in order to analyze them quantitatively. SVD is a method to decompose or measure spectral data into several matrices and extract common characteristics and components. By using the sum of first and second components omega, we extracted and evaluated only those components that were derived from lipid peroxidation. This graph plots drug concentration on the horizontal axis and values calculated from cuff fitting using the right equation on the vertical axis. The effect of LA on the inhibitory activity of drugs was evaluated by calculating the PI50 from the K calculated by cuff fitting. This graph plots drug concentration on This graph shows the PI50 of LA against the concentration of drugs and PI50 of drugs against the concentration of LA. The slopes indicated that drugs reduce the PI50 of LA to the same extent, and that DPK reduced PI50 of drugs 1.9 times more strongly than lidocaine, suggesting that drugs reduce the PI50 of LA, despite the fact that drugs has different effects on the series of reactions than LA. It is possible that LA affects the radical scavenging activity of drugs. To test this possibility, we examined this by ESR. However, in the ESR measurement, we revealed LA does not affect the activity of drugs. Then, why did drugs attenuate the effect of LA? Previous studies have shown that drugs scavenging radical by sex reaction. Therefore, drugs react with radical prior to lipid peroxidation and inhibit the initiation reaction, which may reduce the apparent inhibitory activity of LA. On the other hand, we discussed the results that DPK reduces the action of lidocaine by a factor of 1.9. The log P of DPK is 4.4 and that of lidocaine is 2.4, indicating that DPK is more hydrophobic than lidocaine. Therefore, this result may reflect the fact that DPK is more easily incorporated into lipid membranes. Conclusion: we revealed LA features independent of drugs were extracted, and LA was found to cause a hydrophobic concentration-dependent attenuation or inhibition of lipid peroxidation. Thank you for listening.